All right, in this video, we're going to be constructing a scatter plot, and we're going to be finding the line of best fit, and we're also going to be working on finding the equation of the line. So to begin with, I have a table here. It's kind of big. So I'm going to go ahead and try to plot the dots represented by this table on my graph. I have, as you can see, only the first quadrant because it looks like from my table that all the values are positive. So the positive values are happening only in the first quadrant. So starting with 4 and 6, 4, 6, it would be right here. 1, 2. Oops. All right, so let me erase the extra dots and go again from, we have 1, 2 here. We have 3, 5, 2, 4, 5, 8, 6, 9, 8, 10, 7, 9, and I have two values for x that I don't know their y value yet, but we will get there. So we plotted all the order pairs that were given so far, except the last two, and we're asked to draw a line of best fit. So we are going to be drawing a straight line that passes through as many dots as possible. So let me try to make myself here a straight line. I cannot get all the dots on my line, and that's why it's called line of best fit. So it's not going to be perfectly fitting all your data, so have that in mind. But we're trying our best, our line, to hit or go through as many data points as possible. Now, from my line of best fit, I can use that as a guide to find the two missing outputs. So talking about x is 9, okay, first of all, because the values that I'm given go all the way up to the known value of x is 8, that's the last one. So 9 would be outside of what I already have. So that's going to be called linear extrapolation, outside of my data range. Extrapolation. So again, I'm given values. If you check the x's, the first column, I'm giving values between 1 through 8. So because 9 is outside, that's why it's called extrapolation, outside. I can find the value of the y, or I can predict. I'm just going to trace up the x value of 9 and trace it over. And it looks that a good indication for a y value when x is 9 would be 11. So this value here would be 11. I'm asked now to predict what's going to happen when x is 3.5. Now, because 3.5 is between that data range here, that's going to be called linear interpolation, inside. So again, I can do the same thing. This is the 3, so the 3.5 would be right here. So let me go and corresponds to about 5.5. So these are the values that I got by using my line of best fit as a guide. Now I can always go and calculate the equation of this line. So in order for me to calculate the equation, please use points that belong on the line. So for example, while you're bidding your equation, do not use this dot because it's not on your line. Do not use this dot either, or this. Use dots on your line. So for example, this would be a good dot right here. And another good dot would be this right here. So let me use those two to start building my equation or doing the work. So I chose the 2, 4. And then I chose this one, which is the 4, 6. I need to find the slope first. Again, x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. It's 2 over 2, and my slope is 1. So m equals 1. Now, for the b value, I can predict that it's about, I can see it here that it's about a 2, but I can also go and find it. I can use one of the points, whichever I want, and the m to build in to find my b. So I can use this point. So that's going to be my x, that's going to be my y, and I can put them in y equals mx plus b. Y is 4, my slope is 1, my x is 2, if I go with this order pair, and I don't know the b. So I have 4 equals 1 times 2 is 2. And if I get b by itself, 4 minus 2 is 2. So I'm getting that b equals 2. So from these two boxes, I can write down the equation of this model. It would be y equals 1x, which is x, plus 2. So now that I have my equation, I can find out more order pairs or any order pairs that I want to. So if I use the equation to predict what's going to happen when x is 9, which is was the output that I was missing, you can clearly see that if I put here x is 9, I'm going to get 9 plus 2, and I'm going to get the y to be 11, which is what exactly I got from the line. If I put my x to be 3.5, I'm going to get 3.5 plus 2, and that would be 5.5, which is what exactly I got from the line. Sometimes between the line and the equation, I can have a little bit of discrepancy. The numbers can be slightly different because, again, we're talking about line of best fit, so not everything would be exactly the same, but they should be very, very close to each other. Let's do another example. Now I'm just going to be reading to you a problem, and I'm going to be setting it up so we can come up with the equation. So it says here that the median price of an existing home was $160,000 in 2000 and $240,000 in 2007. If X represents the number of years since 2000, use these data points to determine a line of best fit for the trends in the price of existing homes. Write the equation in slope inverse form. So housing, and I'm talking about money, and I'm talking about years. So here's what I was given according to the problem. I was given that in year 2000, a median price for a house was $160,000. And then in 2007, the median price was $240,000. So to be building this problem, I need to remember that X is years since 2000. That's where I'm starting. And Y is money. So I can start by finding my slope. So let me label X1, Y1, X2, Y2. So I have M equals Y2 minus Y1 over X2 minus X1. Subtraction on the top gives you 80,000, and subtraction on the bottom gives you 7. So if you divide the two, you're getting 11, 4, 2, 8, 5, 7, 1, 4, 3, and so on. So let's say about 11,428.6. So the slope in this specific scenario, in this specific problem, because you're dividing money over years, it looks, and houses, of course, right? You're talking about houses. It looks like every year that goes by, the value of a house increases by about 11,428.60. That's what it means. So I can set up a model for this problem. Y equals my slope, I just got it. I'm increasing by 11,428.6 about X. X is the year, okay? And remember, your starting year was 2000, so your base year is 2000. So your B value would be 160,000. That's how much a house was in your base year, which is 2000. So having that in mind, I can go ahead and calculate what a value of a house would be today. If X is years since 2000, and then I will have 2020, if you replace the X with 20 and you multiply, you will get the answer. So let's do it anyway. 11,428.60 times 20. And then if you add 160,000, that's going to give you that a medium value of a house nowadays would be $388,572, according to this model. So there you have it. You know how to plot points. Just plot them correctly. Use a ruler to make a straight line that goes through as many data points as possible. You can clearly see if you have a trend within your dots, a pattern. You can see if the line is increasing, if the line is increasing from left to right or decreasing. You can start setting up an equation or a model if you want to. Don't forget about linear interpolation or linear extrapolation, and the pattern from your dots or the building up of the equation can help you find other order pairs, the ones that you have within your data or outside of your data.